Well, welcome back. Back to the videos. This is going to be a little bit different here. I'm making this video for my classroom, and I've got what you see here on your screen, here on my computer screen. It's some new software that I got that helps us see things a little bit better, some animations. And so I'm going to walk you through one of these just to give you kind of a basis for extending the concepts that we learned in class Tuesday or Wednesday. And what we see here, this blue curve, is our f of x. And we see a point P on the curve, so I just want you to be kind of exploring with me here as I walk you through it. Point P on the curve that corresponds to the point just above. When you pick a value for x, you can see there right above that is the point P, so P depends on x, and we can draw a tangent line at point P. And remember, the idea behind this first part of derivatives is we're in search of the slope of the tangent line to the curve at any certain point. And the slope of the curve depends on where P, or where x is, and then the corresponding value of P. So then we can want to introduce this notion of x plus h. So h, we can modify h, or we can drag it to wherever we want. So we can move, I think we can do this. Okay, so you see as I move h, the value of x plus h changes as well. So the length of h is this guy right here. I can't point to it, but this value of h, as we change the length of h, it moves this other value, x plus h, away from or towards that value of x. So anyway, we can mess with the length of h. And then what we want to do here is we want to create q. And q is the point that corresponds to the point, or the x value, x plus h. And so we can see the point P is f of x units high, and the point h, the point Q is f of x plus h units high. Okay, so we did that, we created point Q, and then we talked the other day about this secant line, and we just drew the secant line through points P and Q. And so points P and Q are just two different points on the curve, and we could easily find the slope of that line through points P and Q. And then what we can do also, though, is, again, we're trying to figure out what the slope of the tangent line is at P. And so the idea behind this is we're going to take the h, and we're going to let h get smaller and smaller and smaller. And as h gets smaller and smaller, look at what happens to the slope of the secant line. And notice that the slope of the secant line gets closer and closer to the slope of the tangent line. And we call this the limiting value. In other words, the slope of the tangent line is the limiting value of the slope of the secant line. And so I'm going to go ahead and animate this, let h go to 0, and you can see this over and over again. You can see as h goes to 0, the secant line approaches the tangent line, and therefore their slopes are getting closer and closer together as h gets smaller and smaller and smaller. And as h goes to 0, let h equals 0, and then we have P and Q are on the same value. So let h go to 0, we can see it shows that. Anyway, show the definition of the derivative, and the definition of the derivative, as we move that right here, we can see that that's what we talked about in class, that the derivative is the slope of the tangent line, and it's the limit, and there should be this little subscript down here as h goes to 0 of the difference quotient. And we're just using a little bit different terminology. The other day, the way this was different, I'll show you that. This is different than the other day because here we're seeing that the actual derivative, we don't have to just find the derivative at one particular value of x. We're actually expressing the derivative as a function of x. Okay, because you're going to get functions here, and I'll show you how that changes. But I'm going to reset, and then we're going to show the tangent segment at P, line RQ, and let h go to 0. And when h goes to 0, we can see, well, that's kind of an interesting thing. Show the numeric derivative. Numerical derivative is, that's actually pretty confusing when I look at that. So maybe we shouldn't show that. Okay, now let's not show that. Let's reset. And let's see if we can change the graph around a little bit. And kind of more interesting when it's something like that. Let's do that, and let's see if this moves or anything like that. Okay, move it around a little bit. And let's try this tangent segment. I can't really see that well. Create Q. Right there. Yeah, it's not so hot. Let's change this around a little bit. D, how does D affect that? It's better when P and Q are farther away, but they have more of a difference in them. Let's see if we maybe move point C. Well, let's try point B. What does that do? Yeah, not a whole lot. I think point E is our best bet. No, wrong one. A, maybe that's our best bet. I'd like to get point P in a different place. So you can see this is not easy to manage here. So let H go to 0. Probably want to show the secant as getting closer. So